started. So welcome to our third cyber seminar of the winter of 2015. We presented previous ones giving everyone an update on our progress for the Critical Zone Data integration project that I'm leading, and you can see my team members here. We just recently received a no-cost extension for 1 more year, and in that year we will focus on improving the Critical Zone community and data managers, particularly through the Information Management Committee, for which most of you are members. We are really excited about wrapping up a lot of our products, and which we will be demoing some of the newest ones today, and we will be finalizing them this spring with your input. So as I presented last week, we have grouped the 13 major tasks with all of their subtasks into 9 major deliverables. And we went through that list in detail, last week. Today we're going to focus on some of the newest features, which are the visualization system under viz.criticalzone.org, the new control vocabulary system that we're developing for the use for CZOs and others, and then finally where we've gone with display file version 2, which will be the new format for sharing data sets, Earth and environmental data sets, observational data sets, in a way that allows granular record-level integration. So we've presented previously the products that have been live now for a while. CriticalZone.org is of course, our major web platform, and we have data pages that describe our efforts. We've created a search portal, and we have a visualization portal that's been rapidly expanding in its features, and that's one of the things that we'll discuss today. So if you want to learn more about what we've done and where we're going, you can read this report, which is posted on CriticalZone.org website under National Publications. It's also tagged with Cyber Infrastructure. It's listed as a report, so that's where you'll find it. It won't be under papers, of course. So anybody can download that and look at it, and it's a hyperlinked document that, as a PDF, that kind of sends you to all the different relevant places on the web, which we're quite excited about. So with that, I'm going to hand over the presenter ball to my colleague Emilio Mayorga, who's been overseeing the viz.criticalzone.org platform, or the Critical Zone Visualization System platform. So Emilio, let's see here. I just gave you the presenter ball. Should be passed over to you. And PowerPoint is giving me a mess. So now everyone needs to go over to their quick start menu. And Emilio, when you do that on WebEx, hit the share screen button that's in the middle.
Okay, thank you.
So there's there you go. So there's a kind of a set of tabs at the top, and now all of you should be able to see. If you go to Emilio Mayorga's screen, you should be able to see his screen, and then you can click on the little diagonal arrows at the top of that screen if you want to expand to full screen. All right, Emilio, we can see your Chrome web browser, and looks like you're ready to go.
I think so. Tell me if you can't hear me well. I'm trying to get my phone close by enough. The data visualization portal component of the CZOData project ingest data from other sources, from other CZO data. In particular, the main scope or the main priority has been time series data that ultimately come from the display files that data managers have been uploading. And you may recall that those display files are ingested by San Diego, by what's called CZO Central, and turned into web services. So we access those. The idea is that we will be accessing those to present time series views of that data. Probably most of you have seen what I'm showing right now, which is the front page to this application. It's divided by individual CZO. We call each of these an app in the context of this visualization system. So each of these CZOs is represented here. Some, especially the newer CZOs, don't have any data loaded yet. And I'll be showing a subsample of them to illustrate some features. So for example, for Southern Sierra, oh, and by the way, that's the live URL, but Anthony has probably sent that out. I should say also that some of the features I'll be showing today are actually only on our testing version of this application, but they'll all go live. Everything that I'm showing today will be live by the end of the week. Right now, I am showing the live version, and just to illustrate some of the features for Southern Sierra CZO, you can see that there is a pop-up for users with brief blurbs about that CZO that was provided by the data managers. Click on it, and you get to the an application focused on an individual CZO. You have a boundary that we've added, a GIS layer provided by the data managers. And these are the sites that so far are available via, like I said, ultimately from display files, but they go through the San Diego CZO Central. In this app that I'm showing right now, there's no data or time series shown. We're working on that, and again, that'll be available by the end of the week. I will show you time series visualizations only on one app on our testing system, and that's the Lokia one. But here I just wanted to give you that overview of core functionality and core information. So we can go, the listing of apps is always available. You can always navigate to another app, another CZO, or go back to the front page. Just a second, sorry. I'm going to switch now to our testing version. I don't want you to see the URL because it would only confuse you. And again, I'll focus on Lokia because there are certain features that are there right now that are not in other apps. First, I wanted to, I'll go through something that is generic. Every app has this. We are able to load some basic GIS layers. In this case, they represent boundaries. I'm going to turn this off to make it more obvious. And we have two kinds of boundaries. One is the outer boundary, there you go, the red, of the CZO. And another one is a boundary of regions and field areas. Again, both of those are provided by the data managers from the CZO. So those are navigation aids. These are complemented by what we call regions. They're sort of like spatial bookmarks that match those regions. For example, the Rio Blanco watershed. Or we can go to a field area, the field area and Beasley Cabrera 3. And I'll bring back sites to give you a point of reference. So again, every app will have this. Right now, about half of them have this shapefile. All of them have the outer boundary of a CZO, and about half of them have subregions. And we're working very actively on that right now. We'll go back to the whole CZO. I'm going to turn off this IGSN and get back to it later. So what we're seeing here, sorry, some of this terminology will change very soon. This, what's called fixed platform, will become time series. Right now, these are the 10 sites that are available via display files from Lokia. I grouped them temporarily into these categories, soil sites, stream sites, or weather station. Those categories themselves are in flux, so don't worry about that too much. You can navigate, for example, to navigate to one, you see expanded information about the site, names, basically. let's go to somewhere here, the Bisley Cabradas. And I'm going to focus on one of these. And this lists all the variables that are measured at that site. Again, coming from that, ultimately from the display files, and but via this web service from CZO Central. We're still working on refining this specific listing of variables and some of the names here and units. So you may see a mistake here right now, but let's not worry about that. When you select on a variable, this time slider or time visualization pops up that allows you to see the time series. You can see here for this chart, that just shows the most recent value. And you can see that the most recent value was from 24th of May, 2011. Anyways, you can see, at least for 2010, it's pretty clear. And you can zoom in or out pretty easily or pan around or change variables. Zoom in. I'm using my, well, there are various tools to do this, but I'm using my mouse scroll roller ball, I guess, to zoom in. And there's also, there will be an individual download button for each variable. Right now there's a download, oops, hard to see that. I'm not sure if this is functioning right now, but it will be. So anyways, you're able to pick a site and explore the variability of the time series for the variables. I'm going to close this for a second, actually. Go back to regions, zoom back out to the whole CZO. And another feature that it's not fully working right now, but it might be even within the next few minutes, but definitely by the end of the day or tomorrow. It's this filters that allow you to select based on criteria. For example, if this were working, I could click on this and I would get only the sites, dynamically the sites that correspond to what I'm calling sold sites, or select a specific variable from the list for all CZOs. If that part is not working, what is working is this keyword. So I can type something like calcium, for example. And that gives me all the sites that have measurement of calcium. Or this chart. Ditto. You get 4, or something that is not variables. For example, tower, because I know that there are some tower stations. There's the Bisley Tower and the what is this? This other Bisley Tower. So you're able to refine what information you are looking for. I'll turn off this timeline. This other feature we've implemented, and again, some of you may have seen this already, is the ingest of IGSN sites, at least for CZOs that have registered samples with IGSN. And so far, I know that CSAR is working very actively and working with all these CZOs to facilitate the registration, but at least until now, the only known ones that were easily identified were Luquillo and Shale Hills. So we have been able to integrate a subset of the metadata and of IGSN samples. In this case, they all happen to have been classified as soil, so I'll close this off since this is not useful. But I'll click on some of these. And again, this is not the complete metadata information available for each IGSN. This is intended to be a launching point so that a user can see where IGSN samples are found in each CZO in the context of other data or other spatial information or other criteria. And then if a user is interested in the complete information, you can just go to CSAR. I think, let's see what that did. I don't know if that opened, that must have opened another tab. Just a second. There it is. So that launched the CSAR web service request that gives you the complete IGSN information. So again, this serves as an entry point for the complete CSAR-based IGSN information, geolocation, some core collection information, some details. Here I'm going to jump to Shale Hills, both to show another, actually, just a second. Go to full screen again. I'm going to jump to Shale Hills, both to show another CZO, but also because the way IGSNs are presented is a little richer in that there are more categories than there are in Lookio. Based on the material attribute, there's biology, rock, sediment, soils, etc. The bulk of the data available for the Shale Hills CZO is in the Shale Hills field area at this time, so we can navigate directly to it, to that field area. And well, again, this would be the same kind of thing we just did. Configure biology. IGSN, that is same information, collector Susan Brantley. Some of these time series sites, for some reason, don't have variables attached to them, and that's an issue at the in the ingest between display files, from display files into CZO Central. So we need to work on that. This is an example. I guess this is another example of a normal time series site. Right now, again, in this app, in the Shale Hills app, we don't have the time series, time slider visualization capability. So that's why you're seeing it something slightly different. Or we're not able to see the time series yet. Lastly, I'm going to show something that we're not going to add in the very near, in the next week or so, but we are going to do so later in the next month or so in the Christina River Basin because of some previous investment, previous histories. We have a number of data streams from sources other than the CZOs. I'm going to make this a little easier to visualize. You can see these are sources like NOAA, USGS, and this Delaware program. And let's see what's that interesting discharge. So we first we'll be rolling out data from the CZOs directly from originally from display files. And then at the CZO Central in San Diego, that will be available in all the apps by the end of the week, as well as with the time series visualization widget that I showed you for Lookio. If CZOs register IGSNs, we'll be able to implement that, to incorporate that in the appropriate CZOs. By the end of April also, we'll start bringing in some of these external data sources, especially USGS. I think that covers the bulk to say. And
Emilio,
yeah.
If you want to show full screen, if you go to settings and hit local scaling, that will work, or it doesn't really matter.
Well,
don't worry about it. You've moved on.
I thought at least the browser was at full screen. Was something else not at full screen, or? No,
I'm talking about full scale of the discharge data that you showed in the USGS time series at the Christina River Basin. The reason it didn't show as full scale is because you probably have settings in the visualization portal set to global scale, y-axis scaling, not local. Yeah, it doesn't matter. Go ahead.
No, I think that covers what I wanted to say.
Yeah.
And open it up
so
for questions.
Why don't we have questions in stages, since we're going to kind of have 3 sections here. So thank you, Emilio. Does anyone have any questions for Emilio about what will soon be available in the visualization portal and yeah, where things are headed or what currently exists. So you have to unmute yourself. If you need to unmute yourself, you can go up to the green bar at the top of your screen, and there's a big mute button right at the top there, or you can also open up your chat box to chat a question.
Oh, Anthony, this is Miguel.
Hi, Miguel.
So will we be able to add like any of those shape files, delineations of areas, or edit any of the ones we have already sent?
You wouldn't be able to do it directly yourself, but basically, working with me, we can enhance or modify what we have added.
Okay.
In other words, this tool doesn't let you, a user, go to it and upload a data set.
Okay. So I just talk to you then.
Yeah.
Okay.
Anyone else? I'll point out that that the time series feature that Emilio was showing right now was developed specifically for the CZOs, and that was a part of the scope of the original project, was for this visualization portal to focus primarily on time series from Quasi's HIS network. Some of the integration with AIDA's IGSN system was really a little add-on, almost a voluntary add-on that's not directly funded by this project, but we wanted to show that there is potentially the capability to have that same kind of integration with the web services from AIDA. And there was some interest in showing all the sites, all the places where samples were collected. So, whereas Quasi keeps track of all the sites where there's hydrological or meteorological variables through the display files or through any other web service that you enable at your CZO, the soil samples and soil pits are, we're encouraging people to register them with IGSNs. And we'll talk more about that for those of you who haven't done that yet. Sue Brantley's team has done a great job of doing a lot of registrations. So when those samples and soil pits get registered, we can place them on the map. We do not, it's not within the scope to display the data that are associated with those IGSNs with the current funding, but we're very interested in discussing that with all of you about the priorities for that, because we do have some choices to make in the next month or so about priorities. There's some money that we could potentially reallocate with NSF's blessing to enhance visualization of things like soil pit data. We'll have to really to talk to you all about that. So that will be a topic of discussion for maybe the CZOPI meeting or the IMC meeting, and we'll talk a little bit more about that later. So any other questions?
I'll add one tiny thing that I forgot to mention that, whoops, sorry, the time slider is still a little flaky because it's literally just, this first working version was just developed. But one thing I didn't show is that it's able to display the individual data locations or data points, I guess. Those dots represent, or those dashes represent the times when individual observations are made.
Can you hear me?
Hi, Sue. Yep.
Hey, Anthony. I finally found my unmute button.
I was just texting your response.
So I went on and looked at the shale hills and, you know, looked at some data points or whatever, and when I pull it up, the metadata that comes up is not very rich. And I'm just wondering, is that because we didn't put it in right, or is this only like a beta version, or will there be more metadata later?
That's a great question.
There's probably, let me go to it directly. There's probably a combination of two things that and you're referring to the, not to the IGSNs, but the time series sites, correct?
I'm not sure I was that advanced. I see two kinds of symbols. I didn't understand which symbols were which. Actually, three kinds of symbols.
I'll answer for both then. For IGSN, sorry, there's a glitch here in the staging version. The metadata, so this is an example IGSN. The metadata that is shown is a subset. It's not the complete metadata. And again, as Anthony was explaining this, the integration of IGSN samples was not part of our original scope, but we were able to bring it in. It would be possible to have all of the metadata. It would be a little unwieldy. So basically the idea here is that this allows for joint visualization and discovery of IGSN together with other data from the CZO. And for complete information, you can just click here basically and go to CSAR, and you get the entire metadata very easily. Now for the other...
now, can I pipe in, Emilio?
Yeah.
So Emilio just shared half of the answer for IGSNs, that for display purposes, he had to select what he thought were the most useful metadata fields. But when he clicked on that ISGSN number, you might have noticed that 75% of those fields were not provided because they're optional and there was nothing entered. So we could, as we really jump into the IGSN effort this spring, we could work with you, Sue, and with the other CZOs to provide guidance on how to fill out those fields, and so that there really is a richer metadata experience there that Emilio could then draw from for filtering and discovery and other things. We didn't provide a lot of guidance in the past, but in a moment we'll see the new control vocabulary system, which will really help with that. All right.
Well, for example, can you still hear me? I assume you can hear me.
Yep.
You know, there's no state or country. So does that mean that when we registered the samples, we didn't put the fact that where it was Pennsylvania in the United States?
Yeah, I think that's correct. Emilio, click on the IGSN number and see the full record. So this is what Emilio decided to display.
Extracted directly from the CSAR web service, and the country said that it was not provided. Same for city. I can go to the, so that's what I'm passing on. I can go to the, I will check that again. Sorry, someone is typing there. You can see country, state, not provided, etc. So that would be a data entry issue that hopefully can be improved in the future.
Yep. So there's your answer. So we can. So but it's not there. You guys didn't load it up.
Okay.
And the
but
other
we can. I'm sure that can be corrected, right? So and there's funding for AIDA to work with you guys to basically update those records or help you figure out how to update them.
Hi, this is Leslie. We can easily go find those samples and update that information. So we will work on that. Thanks for displaying it.
Yeah, and once those are updated, I'll work with CSAR to, well, they'll let me know, and we'll update this. And based on feedback also, we can expand the subset of metadata that is being presented right now. I developed those originally, but consulted them with CSAR, and they seem to be the most important or most useful core set, but they can definitely be expanded. What I'm showing right now is the other kind of data, or the primary kind of data, which is the time series data derived from ultimately from those display files. And there may be some metadata that was originally available that is not shown here because of limitations in what we present. But generally, the metadata is fairly poor also, and that's something we're working on.
All right. I think I'm going to move and pass the ball over to Jeff. In fact, I'm actually going to steal the ball for just a quick minute, Jeff, if you don't mind, and just have a kind of an intro slide here. See if this works. All right. Oh, I was showing too much there all at once. Oh my goodness. All right. So we made a whole pile of decisions about control vocabularies that I was just going to review really quickly. Jeff, were you planning on saying any of this here, or should I go through this?
Go ahead and go through it, Anthony. Whether you say it or whether I say it, it's all good. So just go ahead.
All right. So so I thought I was going to show this in stages, but I guess the first bullet point is that we made a decision in the spring in concert with the CZOData IMC that we were going to basically deprecate the old shared vocabulary system at sv.criticalism.org. Part of the problem was that it was derived from Quasi's control vocabulary system, but there had been divergence, and we realized that that was functionally kind of a pain in the neck. So what we did is that we took it down and merged the new terms that had been developed for the critical zone use back into Quasi's control vocabulary system. So Quasi's vocabulary 1.1 system now has all of our old terms, and for variables, that's where we've been pointing since then. So we've decided to take a totally new approach, or not a totally new approach, but the new approach that we've decided to take is as you've all heard, we are wrapping our data system and the cyber infrastructure of Quasi and AIDA are all migrating to work around the new observation data model 2.0. And in that process, ODM2 actually allows the use of vocabularies from multiple locations, especially for things like variables and methods that are complicated and have a lot of history behind them. So variables, parameters, methods, etc. There is the possibility to point to really any vocabulary that's in use. However, ODM2 gets its power from actually having a lot of relatively small vocabulary lists that together define the types of data really in a really powerful way. And we realized that there were a lot of vocabularies that we needed, and frankly you all needed, that weren't well defined. So we made a huge effort this fall on trying to define these vocabularies by taking the best of terms that were in common use out there by our fields to define things like units, sampled medium, site type, specimen type, and quite a lot of other vocabulary lists. And that whole new system has been, a whole new system has been built around that, which Jeff is going to describe right now. And I'll just make a big plug for Jeff's team. They basically, he built the Quasi HIS system, handed it over to the Quasi Water Data Center, also then, mirrored it to the critical zone control vocabulary system. And one of the amazing things, or really one of the best aspects of that, was that it allowed the community to suggest new terms or suggest edits to terms. Really, not many other systems allowed that in an automated way. And, we know that the system actually was slightly broken for a little while or whatever, but that was something that was really exceptional. Meanwhile, there have been all these new approaches to kind of allow machine-to-machine interchange of vocabularies that are very powerful, but none of those systems have this community input feature. So this new vocabulary system that Jeff just built has both. And so I'm going to hand the ball over to Jeff because, let's see here, Jeff. All right, I'm passing you the ball, Jeff. And I think you have to then manually click on the quick start menu and then the share my screen button or share screen button to actually show us your screen. So Jeff is going to present this new system and its benefits and how we will be using it.
Okay, so hopefully you're seeing the screen that has my web browser with a nice black window with the control vocabulary system. Is that right?
That's true. If you could make it a little larger and go full screen on it, that would help.
Let's see.
Control plus or something like that. Command plus. Yeah, there we go.
Is that better?
Yep.
Okay, so let me just pick up where Anthony left off. Just so you know, the quasi-control vocabulary system that you all are familiar with is still there. It's still running at his.quasi.org. So that's not going to go away. The Water Data Center, I think, is still going to support that. The new system has a lot of features that Anthony just talked about. Mainly, the big focus here is that we realized that we needed to move beyond the hydrologic time series to support a lot of the additional data sets that you guys are collecting, particularly the specimen-based data sets. And this is related to the display file format, which Anthony and Sarah, I think, are going to do some demos here after I'm done talking about the newer version of the display file format and supporting specimen-based data. But the existing display file format that we had just flat out wasn't going to cut it for specimen-based data. It didn't have the right vocabulary terms to describe it, didn't even have the right structures to describe all of that kind of stuff. So we needed a new encoding format that's like the display file format that could support your specimen-based data. ODM 1.1, which is what the existing display file format was based on, didn't have the right structures, didn't have the right control vocabulary terms. As Anthony said, ODM 2 can do all of this, so we took the concepts from ODM 2, we created the next version of the display file format, and in doing that, we realized we also needed to build out all of these control vocabularies, not only that we're going to support the time series data, but also to support all of the additional metadata that was going to be needed for the specimen-based data. So we basically expanded the ODM 1.1 community moderation system for the control vocabularies. The new system supports all of the functionality that the old system had, but we've got some additional functionality. And as Anthony mentioned, we spend a lot of time as the CZOData team working through and seeding a lot of these vocabularies with terms that are either from the existing systems that we've been working on or the data use cases that we were looking at. And so the term lists have been seeded with a whole bunch of terms that we can build on now. And we maintain the community submission and moderation capabilities for submitting and approving changes, which, as Anthony noted, this is not something that a lot of existing software systems out there have. In fact, there aren't any that I know of that provide a nice community moderation system where you guys can go in and submit terms or submit changes to existing terms. People can look at those and decide, try to come up to some community consensus, and then approve those terms to the existing vocabularies. We also added new functionality for exposing the vocabularies in terms in standardized ways that'll make them a lot easier to reference in a predictable and permanent way. So we added URLs that serve as URIs to every single term and every single vocabulary, which is kind of important. And then we made the terms easier to harvest into software programs like the Excel templates that Anthony and Sarah are going to show you. It also makes it more interoperable with other vocabulary systems. So if you go to vocabulary.odm2.org, the system is live. The last couple of pieces that we're finishing up are related to the actual moderation system. So right now, you see my name listed on here as the moderator, but if there's anybody who feels really strongly about wanting to be a moderator of vocabularies for observations related to the critical zone, let us know, and we'd be happy to have help. But just to give you some examples, so in ODM2, we have action types, we have a lot of different vocabularies, and you'll see that the list is quite a bit more extensive than it was before. But let's just look at something like sampled medium, for example. Every single term has a URL-friendly term, so that this first column is the actual term in a URL-friendly form, and URL-friendly means we've gotten rid of the spaces and special characters and all of those kinds of things that wouldn't be friendly in a URL. Each term has a name and definition, as they did in the other system, but if I click on one of these terms like liquid aqueous, each term now has its own page with its definition. Some of these terms are categorized. There's notes in here about provenance. So this particular term, liquid aqueous, was adapted from CZAR material CV, and there's a link back to the actual page where this term actually came from. If this term was adopted from another vocabulary, there would actually be a provenance URI here that would link it back to the system where it actually came from. But if you look at this page in CZAR, there's just a page that has a whole bunch of vocabulary terms on it, so we've linked it in that way. If I want to view an entire vocabulary, I can click on that link, and what this shows me is basically an RDF XML representation of this in what's called SCOS format. And SCOS stands for the Simple Knowledge Organization System, and it's basically a standard for encoding vocabularies on the web. And it makes it so that linked data systems could actually come in here and they could harvest all of these vocabularies, and they could use them with other systems. So SCOS is just a standard for doing that on the web. I could download the vocabulary as an XML file via this other term. If I want to add a term to this vocabulary, I would just go up here and click the new term, and I can fill out the term, the name, the definition, and all of these fields, and then I get to the bottom and I can submit the request. Now, as far as I know, the submission of new requests is live and should work. So if you submit a term, it should actually go into the system. What we're working on right now is the ability for people like me and other members of the team to actually log in and see those terms. They're going into the database, but we would actually be able to see them in an administrative way, and then we'd be able to sort of click through, approve terms, modify terms if they need to be modified. People will get emails when all these actions happen. So by the end of the week or so, all of the administration stuff should also be up and working. If you want to edit an existing term, you can click on the term, then click the edit button, and it actually gets loaded into the page where you can edit the term, and then of course you would submit it at the bottom. So you don't actually have to log in to submit new terms or request edits. You just need to give us your name, your email address, and maybe some little text that gives us a reason for why you're making that request, very similar to what the old system did. And then the moderators will see that and they will approve it or whatever. So that's the gist of the functionality of the system, very similar to what we had before, but a much more extensive list of metadata elements that we now have term lists for. And when Anthony and Sarah now go through the Excel templates and show you where you're entering metadata, it will make a lot more sense where these lists of terms are actually coming from. So,
great.
Questions?
Thank you, Jeff. Yeah, questions. Floor is open, chat box, or unmute yourself and speak. Sarah Damiano, who's on our team, typed the URL to the system, if you didn't catch it, into the chat box, so you can all click on that if you want to take it for a test ride. I will point out that, as Jeff pointed out, there's really a large number of control vocabularies, and the idea is that each list is relatively constrained and small, and by combining them, we get to that really kind of a huge amount of flexibility that we're seeking. And this approach is getting a lot of attention and interest from Quasi, for example. So Quasi, once we developed this and kind of tested out in the critical zone community, Quasi is very interested in adopting this. And I know there are other groups that are also looking at us. AIDA is also somewhat interested. I think that they will be using almost immediately some of the lists that we've come up with, like sampled medium, the one that, and specimen type. I think they're already adopting those, and they will be keeping an eye on other things. So that's why we branded this as ODM2 control vocabularies, because ODM2 has a pretty broad reach, and there's a lot here. So I guess as a lot here, gives us a lot of power, but we will be offering guidance on which of these to use when. It will become simpler as you use it. Any questions?
And I will say this too, we spent a lot more time this time around on actually fleshing out definitions and the full description of these terms, whereas the quasi-HIS control vocabulary sort of started lean and kind of ended lean. We didn't have really good definitions of a lot of things, but a lot of the terms in here we've spent a lot of time thinking about and writing definitions for or adopting good definitions from other systems.
All right. As I change the presenter ball back to me for a moment before I hand it over to Sarah, feel free to ask Jeff any more questions. Everyone's good, huh? Let's see here. There we go. Okay, we're going to talk about CZO display files. So the CZO display file specification was developed by Mark Williams with quite a bit of consultation with Ilya Zaslavsky and David Tarboten. And the idea was that, you know, the standard data exchange format on the web for parsing data out at the time, back in 2010, winter 2010, was XML. And the problem with XML is that it's not very human readable. It certainly can be read by machines, but looking at a complex data set or even a simple data set in XML is really not fun. So there was this idea that came out of the LTER experience that there is the ability to create some type of structure that is essentially a comma separated value table, CSV file, a little bit like USGS does, but then have some specifications or structure on the header so that the machines can read it and parse it. And so that was the idea. So they created an ASCII text file with comma separated values, detailed header with structured metadata. But as they developed it, they realized that, you know, separate files, this was, you know, a classic USGS flat file format, and a flat file is a two-dimensional data array, and it doesn't have that rich information. So they realized that separate sites and methods files were required, et cetera. There were some issues with this approach. One was that there were quite a few parsing errors because essentially we had to we created this format to meet the needs of the CZOs. But we also had to create the software to read it in that automated way, and it didn't always work. And it didn't always work not just because our software was in error, but sometimes it was the specification was not really followed to the T, or maybe the specification wasn't even adequate to describe certain situations at CZO data managers. We also realized that because it was designed around a quasi time series data set, that was, you know, the experience that was brought to the table, it didn't really work so well with other disciplinary data, didn't work with soil intervals, et cetera. And then lastly, the validator only accepted terms from the CZO shared vocabulary system. I already talked about the drawbacks of having a flat information model. So, you know, basically the data transfer wasn't rich enough in its metadata to go into a proper database. And then lastly, the display file did not meet modern archival requirements. The headers with the metadata were often in separate files, and there was no explicit in-file references to required information to interpret the file about the sites or the methods, right? Modern data exchange formats use this linked data approach, where if the information isn't explicitly in the file, then it links to a permanent URL where that information is stored. These were a pile of reasons why we couldn't just say, well, let's come up with a display file format that works for soils, but we actually had to rethink the entire approach to display files to meet the needs of CZOs. And we realized very early on that there would be a huge benefit of wrapping the new version of the display file around ODM2. we wanted to stick with some of the early requirements of being both machine parsable but also human readable. XML just wasn't fun to look at. And is also very bloated and heavyweight in terms of the amount of characters, a huge amount of characters to basically tag everything relative to the small number of characters of information that one actually wanted to read. So, so we came up with a solution, and this is an older file, but we wanted to use some type of syntax and structural approaches that were already commonly used on the web, such as JSON or JavaScript object notation, which is incredibly common on the web. And I'm going to show you in a moment that we actually decided to use a slightly different format called YAML, and I'll describe that in a moment. We wanted to make sure that the header information had enough detailed and structured, meaning multidimensional metadata, that we could also parse using existing libraries. So by going with JSON or YAML, and not only do we can use tons of code that already exists that is really good at parsing things out without parsing errors, but also code that exists for validating against vocabularies and against what is expected. We are okay with separate files, but we want clear links to the files, and so we're really going to follow this linked file approach. So these are ideas that we had in the fall, excuse me, in the spring of 2014 that we discussed with the CZO IMC at the May 29th and 30th IMC meeting that we had, and we slowly worked on this. And I guess I threw this slide in here to basically say that we really saw that there was a potential for this approach to go, again, beyond CZOs, given that so many other data centers, like our major partners, Quasi and AIDA, and potentially others, were adopting ODM2 for their new infrastructures, that we could actually use this display file concept to have efficient, human-readable, yet machine parsable and validatable metadata transfers between these various systems by being wrapped around ODM2. So we're very excited about this. Essentially, we could use these to replace XML, but still retain all the benefits. So here I'm going to escape out of the PowerPoint, and I'm going to show a few presentations, a few examples of what I'm talking about before I pass this on to Sarah. This may be a little bit small, and I didn't think about this. I wonder if I can make it bigger. I'm going to stick with this. I hope this is somewhat readable. You might not be able to read all the characters. Sorry that I didn't prepare for this a little bit better. But this is an example. Okay, it is big enough. I just saw on the chat screen. Okay, this is an example of a display file where there's header information. This is display file version 1. Some information that pertains to the entire document, information that describes what is in each of the data columns, and then the comma-separated data values. We wanted to make this easier to parse. And so if we just simply converted this to JSON, JavaScript object notation, first of all, you can see here that there's some color coding, which most good text editors have syntax highlighting with different colors. And you can see that the information is retained. It's still relatively easy to read. It doesn't look like XML. And yet, reading this with Python or R or Matlab is trivial. It's so easy to do. You just feed it in, and you get this great structured data object out of it. As we were exploring this, we discovered a newer format that is a superset of JSON called YAML that is increasingly being used around on the web, and it looks almost identical. I'm going to go back and forth, but it has fewer characters. It doesn't have those squiggly brackets. It doesn't have quotation marks around all the text. It's basically a much smarter version of JSON. Like I said, it's being increasingly used. So just to switch to basically follow the structures of JSON or YAML any JSON will parse in a YAML parser, and YAML has a lot of other features in it that make it great, and which is why we adopted it. Just that switch makes it much easier to both create and use, and there are all these online validators, so people can throw in their code and it will tell you whether or not it's valid YAML or valid JSON. But like I said, we're using YAML. So, but we wanted to wrap this around ODM2, and I'm just going to show this exact same data set. By wrapping it around ODM2, we have around specifically an ODM2 data set structure, for those of you who know ODM2, and using the ODM2 language, this header becomes a little bit more rich, and there's a lot more information here, and it becomes structured and hierarchical, like I'm showing here, where we can describe the sampling features, which in this case are all wells. They're all sites with the site type of well, and we have that explicit information in here. Same thing with methods, etc. And then we can scroll down and get to the observations. So this actually right now is not our current version. This was a beta version, and I'm just showing it to you because it has that nice sequence. We met, a pile of us met, including some of you who are on the phone here, for a workshop that was convened in early February, where we came up with the new specification. We actually changed the name too. We realized that because this was bigger than just CZO, than the CZOs, that we wanted to move to a name that really was a better description. We didn't really like the name CZO display file because it really isn't just for displaying, it's for archiving and data exchange. So it was a consensus decision around the table to change the name. So we did a lot of this work on GitHub here, and this is the GitHub repository. And you can see right here that it's been deprecated because we changed the name to YAML Observation Data Archive and Exchange format, or the Yoda file format. And we had a lot of fun with that. We hope you do too. It's actually quite descriptive, and it's already catching on. So CZO display files are being changed to the Yoda file format. So if we go back to a Yoda file, this is what it looks like. This is a valid Yoda file that we're working on. It is currently available. Everything is available on our CZOData Yoda file GitHub repository. So you can, for those of you who know GitHub, you can easily go in and clone this on your desktop, or you can just download the whole thing as a zip file, and you can get all these examples, and everything that we're going to show you is being done right on GitHub. The beautiful thing about GitHub is that it's also got issue trackers, and it's got all of our work on this specification is being tracked kind of with a powerful track changes approach, and with the whole discussion about how we are doing this is all public. I'm going to hand this over to Sarah in just a moment. So I'm going to show, Sarah is making a plea via the chat box. Please check out our GitHub repository and comment, and we want to engage with all of you directly as we finalize the specification. So this is a Yoda file in the expanded format. And as you can see, this is actually allows us to map these text files directly into ODM2 with all of its features fully fleshed out. It's really quite exciting, but it also creates a header that can be potentially long when we flesh it out like this. So here we are. We don't actually get to the data values until line 248. So we actually created two versions of this. You can do it this way, or you can use the nested approach, which is what is shown here. And this nested approach is a little harder for a human to read, but it's not that much harder. The machine reads it equally well either way, so they're both completely valid, and allows us to get to the data values by line 74. So this is actually, not that much more of a header, really, than what a USGS CSV file might look like. And we've also worked, so this is one, so the Yoda files have different types of profiles, and this is a time series profile, and it's wrapped around the use case of a data time series, but we're working on creating specimen time series, such as a bunch of water chemistry samples that are collected at irregular intervals out of a stream, or specimen measurements such as those out of a soil pit for geochemistry. And they have slightly different specifications. All of them map to ODM2, and they really have the capabilities of handling an incredible array of our formats for our use cases in the CZO community. So I'm going to change my screen sharing to Sarah, who's going to work through some of the software tools that we are developing to make emitting these, creating these easier, because we realize, even with the Yoda syntax and even with a good specification, that it could be quite a bit of work to actually fill that out properly. With a simple time series, it's actually, you can totally do it in a text editor or even Microsoft Word just by following some simple rules. YAML is that easy. But for complex stuff, we wanted to create a template in Excel that would really walk you through the process. And I think we're very excited by these. We were inspired by what the CZChemDB folks had done for soils and some of the work that we had actually done here at the Stroud Center before. So anyways, I'm going to hand it over to Sarah. Go ahead, Sarah.
So I had a couple slides. Anthony already said most of this. So switched over completely to YAML. Just following ODM2, new controlled vocabularies, bunch of stuff Anthony said. Unfortunately, creating these YAML files, not simple. So made some Excel templates. Right now we have 2 versions in development, one for sensor-based time series data and another for specimen-based measurements. And so these templates, they do require Excel 2010 or 2007 and macros, but they will create a complete, well-formatted Yoda file that can be submitted on the CZO website and will eventually be parsed into a central ODM2 database. Hopefully going to be a lot easier than when people were trying to manually create their display files. Won't have that trouble. Some limitations, just in advance, it is still in development, but we're hoping to have a release out within the next 2 weeks. So we'd really love some beta testers to throw some data in and let me know how it works for you. Using this Excel template, we're going to allow you to put in a lot of data, but you're not going to be able to put in everything that you could in ODM2 without doing some manual work on your YAML. But hopefully we'll get everything that you would actually want in most common cases. And Anthony showed you what some YAML looks like, but just, it doesn't look quite like the CSV you might be used to seeing, and the header is going to be longer. Okay, so that being said, I'm showing you the time series template. So we have some instructions at the beginning, and we have a bunch of tabs. We work our way left to right, look at the different tabs. In all the different tabs, so we're starting with people and organizations. There's the ability to select from controlled vocabularies from drop-down menus. And you see I put something in, and I actually is going to color code me red right now because it's really what it's telling me is that I should have put the first thing on the first line. So I have a lot of things like that. If you somehow put in something that wasn't a member of the controlled vocabulary, it's going to come in red. Tried to make it so lots of warning flags, so something might be wrong before you try and submit it, and you don't have to have everything prepared and submitted and then come back and say, oh, you had this term that wasn't right, you misspelled it. I'm trying to get that right there from the beginning for you. So we've got people and organizations, we've got data sets, you can put in sampling features, you can even relate your sampling features, your methods, your variables, processing levels. Some of these should sound familiar from ODM1, and they're all part of ODM2. Then we get to this final thing where we have our data columns. And here, basically, you're going to say, well, I have column number 1, and this is the data I have in column number 1. You can give it all kinds of information. And then you're going to hit this Generate Yoda File button, and it's going to put out a Yoda file. Right now, if I hit it because it's blank, see it's going to take me over to a new tab where I have the Yoda file, and it's going to basically give me a lot of warnings because there wasn't actually any data. I'll flip over to one where I have some stuff pre-filled out. So you got some stuff in there, all these places.
You can download these to play with them right now on that GitHub site, by the way.
Let's see here, as I said, it was defining all my columns. And this time when I hit my generate Yoda file, I go over, and that was a little macro that ran. And just so you know, if it is a very big data set, it might take a little while to run. Jeff tested it for me with quite a number of variables with a full year of data every 15 minutes, and it took about a minute to run on his computer. So just to warn you. But for my small data set, it ran pretty fast. You can see my data set was only a couple thousand lines long. So I got this data set. I've got, my header's pretty long, so I had a lot of information. At the bottom, I have some data values. So that's time series. And I'll just quickly load through the specimens. Again, I've got one figured out, people and organizations. Many of these tabs are exactly the same. One thing that is allowed in specimens that we haven't yet allowed with time series is the ability to have custom spatial offsets.
Can I jump in and explain that? So a sampling feature is kind of this generic high-level term to describe all the places in which one collects specimens or collects data from the environment. They are actually where data observations are made, and so they can be in situ. So it could be a soil pit or an oceanographic station or a hydrographic station or a weather station. It could be a tower. It could be a transect. It can be all sorts of different things can describe a sampling feature. So the two sampling features that are most used by the CZOs are sites and specimens. So a specimen is a special type of sampling feature, and so if one is describing how a specimen from a soil pit is related to the soil pit itself, the soil pit is a type of site. The bag of soil that comes out of the B horizon is a specimen collected from the parent soil pit, and all of that can be done in ODM2 with these spatial offsets. And so you can type in the min and max depth, for example, of a specimen that's collected from a soil pit. Or I think the examples that Sarah just showed were that sites were within field areas, which is kind of a broader sampling feature. So anyways, that's some ODM2 jargon that Sarah kind of blew through quickly. And we didn't invent that, we adopted it from the Open Geospatial Consortium Observations and Measurements Standard, which has been an international standard now for quite a number of years, more than half a decade.
Okay, sorry. So again, spatial offsets, we can relate our sampling features. I haven't filled these ones in for the samples that I was using to test. Again, we still have methods, we have variables, we have processing levels. We've now added the ability to put in taxonomic classifiers for specimens if you need them. But then we come up to our data columns sheet, and this is where it's really different between time series and specimens. Now we have our columns, and then within each column, we say what type of data it is. So we could have a column of specimen codes. We could have a column of result values. We could have a column of analysis date times. And if I'm going to have a column of analysis date times, I have to say what other column it applied to. So that's the analysis date time for pH. So try to give a lot of flexibility in the type of information that you can put in for specimens, because specimens tend to have much richer metadata than a simple sensor time series. Again, trying to help people out with a little bit of color coding on what they should type in and where, though it's not quite perfect. It's a work in progress. But again, once you're going to fill this out, define what columns are where. You're going to paste in all your data. Then you're going to go back and you're going to say generate Yoda file. And see, this one does take a little longer to run because it is a little more complicated. But you're going to get, go all the way to the top, you'll get another YAML file. And See, this header is much, much longer now because there's a lot more information. So this header is actually several thousand lines long. I apologize about that. But that's how we can get a lot of rich data in here. It's going to be able to be scooped up by any ODM2 database reader, and they can just go through, and you can see there's a lot of information here. I've also set this up so if I had accidentally put in a value that didn't match with my other metadata, so I'd defined a method and then but had put in a method type that wasn't part of the controlled vocabulary, et cetera. Just like I showed you, get red warning flags. You're going to get red warning flags here. Hopefully that's going to help you out and not just overwhelm you with lots of red. So you can figure out what was gone wrong and have some indication that your file is going to be a good file before you send it in. You don't have to have a bunch of emails back and forth about the spelling of things. It should help you out right at the beginning. So I kind of blew through all of that, but if you have any questions, you can put them in the chat or you can ask. And also please look at it on GitHub. Would love to have people play with it and comment, and everything from why'd you choose yellow, I hate yellow, to I really need to be able to enter X type of data that your template doesn't allow.
All right, so any questions for anybody? We are really excited to get your input, as Sarah pointed out, and we're also kind of excited where this has gone. It's been a vision that we've been building for a good year and a half now of where we would go with display files, and I think what we've produced is, again, exceeding our early expectations. We're really quite excited about it. We should point out that the Yoda file specification is incredibly flexible, but these profiles that we're creating, and we showed 3 of them, the time series profile, the specimen time series profile, and then the specimen measurements profile, are the ones that we will be supporting and putting most of our effort on for the next many months. But we could certainly continue to expand as people need. For example, we know there are a lot of people who are taking spectral measurements, and it's been asked, how can I accommodate spectral data? And it would be relatively straightforward to get a working group together from the IMC to define a spectral data time series, specimen measurement, profile, and then we could adapt the Excel generation templates to meet that. If you have spectral data and you're clever, you could create your own Yoda file with spectral data out of an ODM2 database, and we're building tools to read and write Yoda files in and out of ODM2 databases, and then you could submit it and it would work. It would validate and it would work. But in terms of kind of creating these easy step-by-step simplified approaches, we'll need some help on that. And we're just taking on 3 for right now. There's a question or a comment in the chat box about using Yoda file specification to replace ISO 19115. And I'll give a bit of an answer to that. ISO 19115 is a specification that describes data documents, and one of the reasons why it's being increasingly widely used is that it can describe multiple data documents. We explicitly decided that a Yoda file would have a single data array or a data table, data matrix, and that's it. Making it more complicated would be really a pain in the butt. And if we want to, we are going to develop ODM2 exchange specifications that allow multiple data sets to be transferred. They will not use this YAML syntax that's way too complicated, but they will almost certainly be built around SQL-lite database files, which is a file-based data system, SQLite. They're binary files, and they can basically fully represent multiple ODM2 data sets in its full-blown complexity. YAML files will not. Yoda files will not. So ISO 19115 really serves a different need than a YAML file. YAML files are really to describe data arrays, whereas ISO 19115 are to describe a grouping of data documents. All right, we got a bunch of stuff in the chat box. Anyone want to pipe in, or should I read these? Are there additional tools right now? Yes, so in development. So we just presented the Excel templates for creating YAML files by CZO data managers. We thought that would be the easiest for people to get started with. But we're also developing code to read those files, read any Yoda file, actually, and ingest it into an ODM2 database. That same code will quickly be repurposed to emit a Yoda file from a database. So if you're managing your data eventually in ODM2, you should be able to create Yoda files from that. That's a secondary priority and probably not going to be at the top of our list. Those parsers are already working from a structural point of view, and what we're working on right now is kind of an additional layer of software that not just parses it out, a Yoda file out into an ODM2 structure, but also validates all the control vocabularies against this control vocabulary system that you just described, so that we really check whether or not everything is right before it goes in. So there's kind of a whole software family that's being developed around these that will eventually be available as part of the ODM2 package that we will be releasing. For those of you who've been following ODM2, there's lots of different ODM2 software components that are slowly being put together, and we have not yet made a formal release of ODM2. So it's all beta tester stuff right now, but sometime in the next year, we will be making a formal release as actually part of the big CZ project, which we've hardly talked about, but there's funding there to do that. All right. Do you want to add anything else to that, Jeff? Jeff typed in some extra comments about that.
Yeah, so there was a specific question from Sue about whether we had additional tools for loading Yoda files into an ODM database. And I'll just say, in the last week, the developers here at Utah State have actually been working on this. They're working in Python to develop a tool that you could actually point it at a Yoda file, it parses the Yoda file, stores it in an object structure, and then on that object there would be a method that says save, and it would actually write it to an ODM database that you're connected to. So if you're a programmer, then the answer is, yeah, we've got something that is working okay right now. It doesn't have all the validation and stuff that Anthony was just talking about. But the next step is to just build a really simple graphical user interface that you could pop up a little window that says, point me at your Yoda file, click go, and it would require a connection to your ODM2 database. But then underneath it could actually do the validation, it could check things and actually load stuff into your database. So we're getting closer to having that set of tools actually ready for people.
Yep, so as a heads up, almost all the software that we're building around ODM2 and for use by the CZOs, if you're at the command line, almost all that software is based on Python. So we have some behind-the-scenes software that runs on other things, but if you think you're going to want to manage an ODM2 database, those management tools are all going to be written in Python. Which is really, we chose it because it's the easiest and most powerful combination language that is out there right now. Once it's in ODM2 and you want to maybe use some tools in R, that shouldn't be that hard to do. R and Python work pretty well together. And as part of the big CZ project, which we are, which is a 2-year project that is basically building on all of this, and we're just getting started on, the CZ project will release by the end of those 2 years a toolbox, kind of a relatively easy to install package that would allow one to have a lot of these tools that we're talking about relatively easy to install on your data server. We haven't really fully defined all the functions yet, but these are the kinds of things that we're going to do. But that's not part of the CZOData project. It's a much bigger effort with a longer timeline, and that deliverable will definitely not be completed until 2016 sometime. Anything else? All right. Thank you all for hanging in there. We almost went out to an hour and a half. Really appreciate your attention. We'll be in touch. We want to do more of these over the spring. And I'll be in touch via email about input that we want, about the date of the IMC meeting, and also about fleshing out the IMC faculty representatives. Thank you all.